Okay, I'm going to explain every problem here from your last review packet that you just turned in today. Number one, find the lines of symmetry of the given figure. Remember, lines of symmetry means where can I draw a line, even though I don't have arrows on them, to so that they will reflect right back onto itself, the same shape, and that is the horizontal and vertical lines right there, splitting the figure in half. Okay, and will reflect right back onto itself. Uh, find any lines of symmetry for this one. There isn't. You can't go vertically because obviously this does not reflect in the same shape over here, only horizontally. Number three, planes that do not intersect are called parallel planes. Remember, planes are already in space, so if they don't intersect, they're parallel. And what are they? They're planes, they're not lines. Coplanar, remember that means in the same plane. So lines in the same plane that do not intersect, that is our definition of parallel lines. This has been a DCAS question, whether it's worded just like this or maybe in the reverse order, etc. We need to know. Parallel lines must be in the same plane. If they aren't coplanar, so they could be in space, well then if they don't intersect, they could be skew lines. Remember that. But if they're in the same plane and they don't intersect, they are parallel lines. A segment consists of two endpoints and all the points between them. Heck, I even think I saw that on the DCAS. I couldn't believe how easy of a question that was when people were missing that. Okay. As a reminder, as I told you in class, any questions that are on here or the last one review that we turned in the day before this, class before this, I could put on as review problems on your quiz and tests coming up for the rest of the year. Okay, it might be the exact same question. Okay, or I might just change the numbers. Okay, so you're going to be reviewing this when you study for quizzes and tests as well. And here are the review sheets, this packet and the other one. All right, what geometric shapes? I circled the word shapes because it's plural. That means several, you're only giving me one. You're only giving me the trapezoid. But remember, we also, right below trapezoid in the quadrilateral hierarchy, is the isosceles trapezoid. They both only have, or can only have, one pair of parallel sides. So the plural of shape should have told me I should be given two answers at least. Shape of the cross section. A cross section, if you didn't know what that was, you could just Googled it, and they were showing you plenty of cross sections, geometric cross section, and it would give you plenty of these. And so they're obviously highlighting it here for you. A cross section means a slice. If I take this rectangular prism and slice a horizontal slice through it, it'd be the example would be this slice, and what it's asking what is the shape of that? It's a rectangle. The DCAS might ask for a vertical slice. It would also be a rectangle. Or it could ask for an oblique slice or slanted slice, okay? And that would also be a rectangle for rectangular prism. We'll look at more at those in three-dimensional objects in second semester when we deal with prisms, cylinders, pyramids, all that. We'll also talk about cross sections there as well. So that'll be mostly focused uh, in second semester. Okay, this was just a simpler one because it was a rectangle. Nothing more complicated than that. All right, so if I was to construct a perpendicular bisector, this is a major, well, two words that you need to have down pat because this is going to be the answer to at least one or more questions on the DCAS. It could deal with constructions, or as one of the other answers on this page is, or the back side, one of those, I can't remember which, the answer is perpendicular bisector. So it doesn't have to necessarily be a construction of how to construct it, which you do need to know, which as it says here, put the pointer on A, draw an arc, make sure it's opening greater than halfway, more than half of this distance, and then draw an arc. And of course, that's the first step. You turn around, do the same arc the other way, and then go ahead and do it. Connect them for your perpendicular bisector. Remember, perpendicular means 90 degrees. Bisector means it splits it in half. Okay, so we could put hash marks there after we constructed it with a 90-degree symbol, perpendicular symbol. All right, 8, we have a quadrilateral. We're looking for this angle right here. We know the interior angles of a quadrilateral add up to 360. So you have 90 plus 90, which is 180, plus 116, plus this x is 360. Solve it and you get 64. Another quadrilateral, so again, it has to add the 360, add those three angles, plus the fourth angle, C, which is called x. Solve it, and you get x equals 81. Um, Number 11 here, find the measure of one interior angle of a regular polygon. So again, if I didn't remember the formula of n minus 2 times 180, I could draw the diagonals from one vertex only. Boom, that diagonal, that diagonal, and that diagonal. Each one creates a triangle, 180 degrees, 180, 180, 180. Four times is 720 degrees. That's the total interior angles of this convex polygon. Okay, also a regular polygon. Remember, regular means equilateral and equiangular. You need to have that down. Okay, these are the mostly of the types of polygons they're going to have on the DCAS are regular type of polygons. In this case, 1, 2, 3, 4, 5, 6 regular hexagon. Be this description. Okay, and so I take the total degrees divided by the total number of angles, which is 6, as we just said, and that gives you 120. Point E right here is called the what of segment BD. It's called the midpoint. It's the middle point on segment BD. We know that because of these hash marks tell me that they're congruent. So this is the midpoint. Number 11, n minus 2 times 180 had 7 sides. 5 times 180 is 900. I add up all the angles, and of course, the one is x there. Add up all the given angles. It's 769 plus x is 900. It's subtracted across, and x is 131. Here's our other perpendicular bisector again. Told you it's key. You had it up here, and now you have it again down here. So a lot of you only put bisector or perpendicular. It's both. How do we know that? There's the perpendicular, and here's the bisect part. And I drew that sometimes on some of yours. I put bisector, and I drew it to both the hash marks, showing that this bisected that segment. Okay, that's how you show bisector, and that's how you show the perpendicular symbol. So it's a perpendicular bisector. All right, backside. All the points on AC, which is what we just said, is called the perpendicular bisector of this segment. Okay, so perpendicular bisector, key. This is going to be on the DCATs. It's been on it the last couple of years. And it's going to be a question like this, similar to this. Okay, any points on the perpendicular bisector are always equidistant from the endpoints, B and D in this case. So if I take that point from there to there is equidistant as it is from there to there. Or if I take this point from there to there is equidistant as it is from there to there. Equidistant. Remember that that's what the perpendicular bisector theorem says. Remember we had that perpendicular bisector theorem on our first unit review packet. Okay, so you can even go back and see it there. All right, number 15. Use the figure of the right to complete the same. Ray AE, remember that's a ray, and A is the endpoint, goes through E forever. Okay, is the bisector of angle BAC, or you could have said angle bisector, either one. Drop down menu, they'll have one or the other, either angle bisector or bisector. If they had both of them, you would choose angle bisector because you're bisecting an angle. 16, all the figures, right? Okay, use the figure here. All the points on AE, well, that's an angle bisector. All the points on the angle bisector are equidistant. Here you see that word, which is our answer up here, equidistant from the sides. I circled the word sides here because almost all of you gave me an angle. An angle is not a side. Angle BAC is an angle. It says sides. The only sides here we have are ray AB and ray AC. These are my sides of this angle. So it's ray AC and ray AB. So any point on here to this line is equidistant it is from this line. That's what they're showing you right here. Okay, when you go from any point on one line to a point on the other line, it's always at a perpendicular distance. That's the shortest distance between any 2 points is the perpendicular distance. Okay, so since that's 12, this should be 12. This is 15, this should be 15. Okay, very similar to the perpendicular bisector theorem. And you how to use ray symbols as well. Name three collinear points. H, A, and X are the only ones I can say here. Remember, N is not a point. Notice, remember, points are labeled as capital letters. Some you write in the word point H, point A, and point X. You don't have to write the points. Write the word point. The letters themselves automatically mean point. Okay? And it must be capital. I saw one or two people writing lowercase. You cannot use lowercase. I told you this from day one. It must be capital letters, just as you see here. You cannot use N because N is the name of a law of this line right here. One way to name this line. Remember I told you one way to name lines besides using 2 points on the line with the arrow, a line symbol above it, is to use a small lowercase letter at the end of one of the arrows. The N could have been up here. Or collinear points are points that lie in the same line, collinear. Not the same line, it would be non-collinear. They said not collinear, but the technical correct word would be non-collinear, which I wrote right down here. Okay. Uh, Errors that people, when I said you could use either this one or this one, somebody used, I think they were using this up here, unless I graded it wrong. And they use this D as a point up here. They must like D, H, and X. D is not a point. Remember, D is another way of naming this plane. I told you you can have a capital letter in one of the corners. It's one of the ways to name a plane. So again, this is review. Or I pick three non-collinear points to name the plane. I'd have a plane symbol. Excuse me, it looks like a parallelogram. That's a plane. And then three non-collinear points, H, A, and L, or A, X, L. Cannot be three collinear points. So you either name a plane with three non-collinear points or use the capital letter that's in one of the corners and it's not a point. You don't see a point next to it. So somebody, I think, in this problem said like D, H, and X, and you got it wrong because D is not a point. Down here, D is a point. You see the point right there. And when they intersect right here, that's the same thing as a point. Okay, they just didn't have it there. So all four of these are points. And they wanted three non-collinear. D, S, and F. You could have said D, F, and Q. Okay. Here, name three non-collinear points. Select all that apply. This could be a TCAS question itself because you can see the select all that apply. So I just make sure it's not S, W, and P. So it's not SWP, it's not F, and it's not BWV, it's not B. It's all the others because they only contain two of the 3 points on the line and one on the other line. Okay. 21 said to plot these points. You plotted them right here, and they are collinear. Some people just plot them and didn't state. It says state as they appear to be, whether they appear to be collinear or not. You had to say collinear or non-collinear. Okay, you can't just graph it and do it. The whole key word is whether you understand the word collinear versus not collinear. So if you left it blank, you got it wrong. So collinear, and I plot these ones. You get this point, 0, 0, -4, 2, and then 1, -2 down here. Obviously, when I connect that, this 1, -2 doesn't even come close to touching the line. So non-collinear. Okay, and that will end it. 13.5 minutes.